grid management, leveraging EDGE DERMS and Bitcoin Lightning to unlock customer flexibility by our colleague Juan Carlos Oviedo Cepeda. Please welcome to the stage.
Hi. I will talk about electricity, energy, and Bitcoin. It's very connected to the last talk. It's going to be Jack, he was the last presenter. He was talking about what if in the future you can provide services to the power utility and the power utility can pay you in Bitcoin. So I work for a power utility. That's what I'm going to be speaking about. Yeah, thank you. So I will try to explain something that is very technical, but if something is not clear, please tell me and I will try to explain better. I will just want to present the idea, the technology, and what is the future. So there is new type of businesses nowadays that connect people to allow them to do something, to provide a service, and on the other side there is someone producing the service, selling the service. So for example, Airbnb, you provide a house and then you connect someone offering the house with someone that needs the house. Uber is the same. You provide a car and there is someone that needs a car and there is someone operating the car. But these businesses require someone actually doing the job. It requires someone preparing the house. It requires someone driving the car. In the future, what if we can build businesses that you offer a service but is powered by an artificial intelligence, and then you don't need the human anymore? Is the artificial intelligence the one that is providing a service in the real world, and then you will get paid for that? So this is the type of business I want to propose for the power utilities. So you need something that is actually able to create value. That's what is paid in the real world, the value. If you are driving the car, you are adding value to the one that needs the car. So if you take a power utility, and now with the energy transition, they want to make everything green, they want wind energy, they want solar energy, and the energy production starts to fluctuate a lot, and then you want to use the flexibility of the users. So let's say you have an electric car, let's say you have a water heater, let's say you have a space heating, you have thermostats, and the power utility wants to use those devices. It wants to take, for example, and discharge your electric car. It wants to change the settings of, for example, here is very cold, it's not needed. So for example, the power utility say like, okay, they are consuming too much, I will modify the HVAC system. But what if the utility is able to do that, but instead of giving you like a credit or instead of saving something in a database, it pay you directly on Bitcoin, okay? So what if you can design a system that can control the devices available on the buildings and you can get paid in Bitcoin? So I will say it easy. You have in your home an electric car, the power utility wants to use it, they use it, and they pay you in Bitcoin for doing that. So that's what I'm doing. And the idea is like, if you build that kind of system, it's something that it is interesting for the power utilities. They would like to use it. And like you are putting Bitcoin like camouflage, like inside, and they will end up accepting it. So I have that kind of system already built and deployed. These are some buildings in Canada. You have here, there are two houses. connected. They are exactly the same. There are two sheds. There is a big building. We have electric cars. We have space heating. We have water heaters. We have different technologies. You can see the technologies installed in each building. And we can control those technologies, okay? That's what I'm going to show. So this is the set point of those buildings now, okay? This is the consumption, the energy consumption of those buildings. This is the temperature in each of the thermal zones of the building. And you have here the historic of the set points that I control it since here until Canada, okay? So what I'm going to do is I will change something for the space heating. I could do it also for electric cars. I could do it also for other technologies. But I will change something for the space heating, and I will pay those users in Bitcoin, okay? So I deploy an LNBits server, and you can see here the buildings I was showing before, okay? Give me 1 second. So those buildings, like the two houses, like the two sheds, like the building, the big building, they are here. So I create a wallet for each of the buildings. You have the two sheds. This is like the power utility. You have the big building and the two houses that are exactly the same. So those are the wallets for each of the buildings, and I will take a screenshot of the initial state. So this is the initial state before executing the action. So now they are 23, so I will change the set point for, let's say, 18 degrees. And then execute. Okay? So this in the future could be like an app on the phone. It could be something that the power utility manages directly, okay? And they will not see anything of this because this is like the programmer's side, but in the future it will not be like that. So you say here, okay, the system is sending the information. It requests an invoice, so each user decide how much he wants to charge. Like, I want $1 for the service you are requesting me. All the invoices are sent back to the power utility. Then the power utility pay the invoices that they want. So they choose like the cheaper kilowatts available, and then they pay. And once they pay, the users receive the payment and execute the action. So before you saw that all the thermal zones were 22 degrees, now they are 18 degrees, and they are slowly changing. So why we would like to do that? Because you can do this kind of thing. You can play with the power consumption of the buildings. And if there is like too much demand on the power system, we can just reduce the demand. If there is renewable energy available, we can increase the consumption. And of course, without affecting the comfort of the users. And so here, this is the original state. So if I refresh here, you will have the final state. So you can see here, for example, this building received a few sats. Originally was 416 for this building, now it's 438. This one originally was 478, now it's 497, and so on. So the buildings were paid because of the service that they did, okay? And what is interesting about that is that when you make the simulations, and you see, for example, what if a user started in 2020 and I pay them $100 each winter for their services? What if instead of paying in dollars, I pay them in Bitcoin? So in dollars is like $475. In Bitcoin is $1,800. If the users hold the Bitcoin instead of selling the Bitcoin. And if you make longer simulations, like for example, starting in 2015 with the same amount, you will have around $1,000 until now. In Bitcoin, 64,000. So imagine that you install the system that can be controlled by the power utility and you just let it run. So you start to make an income without doing any work. Because all this is managed by the intelligence that you install on the system. That's what we do. You install it on the system, and it communicates with the power utility, and everything is doing in the back end, is behind. You don't see it, okay? So, that's the main idea of everything. That's my contact. If someone wants to contact me, it's something we are developing. There is a lot of challenges for doing that. And I could go into the details of the challenges that power utilities face and control people face. But I think I would prefer to take the minutes left to, if people have questions or want to say something or to listen what they think. Yeah. I cannot hear, sorry. Yeah.
What's the smallest incremental rollout strategy you could have for a system like this? Like, do you need the big grid operator to be bought in to roll something like this out, or what's the smallest unit you could roll it out at to see people benefit?
I deploy it in 4 buildings, so you can deploy it at any size. You can deploy it in a community, you can deploy it in a microgrid, you can deploy it in a city, as small as you want, as big as you want. There is no technical problem of doing it. The problem is the same as politics, is political will. Let's say people actually want to do it, and the same as the guy before was saying, everything is amazing, everyone like it, until you mention Bitcoin, and then they are like, oh, yeah, okay, I don't know. So, but yeah, you can deploy it at any size, and you can deploy it with any type of load that is controllable. So smart thermostats, water heaters, electric vehicles, batteries, thermal batteries, planchot chauffant, floor heating, whatever you can control, you can deploy. Yeah.
Hello, thank you for your presentation. Based on your experience in Quebec, I believe you are from, right? How do BESS, the battery storage systems, are considered in Canada? Because we just were on another presentation from Texas, and they consider like a distributor company that you can organize based on BESS. So what is your experience in Quebec?
We have few batteries, and we do have thermal batteries as well. But I mean, if you ask specifically for Quebec, the problem is the electricity is too cheap. So when you make the financial analysis, the numbers doesn't round out. It's like the ROI is like 25 years. It's like financially it makes no sense to invest on those kind of technologies because energy is just too cheap. So energy will increase the price, that's for sure, and these technologies will take more adoption. especially thermal batteries, is something that makes a lot of sense in Quebec, considering the cold. But yeah, we can control those technologies as well. Yeah. So yeah, I don't know. What do you think about the idea? It's something you will like to see, something that you will like to have? It's the idea itself. It's simple, but I think it's something that could be interesting in the future. Yeah. So if there is no more questions, I think I don't know. Maybe we can take some time to rest. This is more related to the challenges that you have on the field to deploy this kind of thing. But this maybe is more related to people working directly on energy. So I don't think I will enter into the challenges. Yeah. The mic is behind you.
Yeah. Okay, I have an area I have an area of interest and of experience, which is in the healthcare field.
Healthcare.
Healthcare, yes.
Okay.
So I appreciate the fact, and throughout our presentations, that the central role of energy and therefore the central role of Bitcoin, you know, starting from there. Anyway, my focus of my application, if I understand how this could be fantastic, because if you start with, let's say, Bitcoin / energy, and then you go to the peripherals. In my case, the peripherals are audio and video for distant caregiving, connectivity to equipment that's attached to a bedridden individual, connection to heat and cold in the kitchen in terms of preparation, connection to gaming devices that grandchildren can play while the grandpa, like me, watches in joy at a long distance caregiving call, which normally the caregiving call is, "Did you take your medication, Mom?" And you know, that's not good enough. You want a lot more, particularly when there's love involved. You want time, you want to do things, you want to share things. So those are all the peripherals. But if you have in the background the energy / pay system, what they call sometimes the pay wall, if you have that kind of, I don't know, integrated in some way, the way you're doing it, then you could really have a very nice little enterprise where you go to any elder care facility and say, "I can introduce you high quality, long distance caregiving, and we'll just watch everything that's going right on that dashboard."
Yeah.
Now, am I absolutely out of order?
No.
Short?
Actually,
if I need rehab, tell me, okay?
Yeah, actually, it's interesting. That's what we try to do only for energy, but of course you can extend it to other fields. But then you arrive to the real problems of the real world, and what you have is you have multiple providers of the technologies, and integrating all of them in one unified solution is actually very complex, but technically it's possible. Yeah. So yeah, thank you very much for listening to the talk, and yeah.